Hello and welcome to tonight's stream, and we are continuing from where I left off. But first, I'm going to tell you about the book. It's Algebra and Trigonometry, and this is part of the OpenStax initiative through Rice University. And you can download the book in the video description. It's free. I have a physical copy. It's a very nice book. I highly recommend you getting it. And if you look at the answers in the back of the book, you're actually going to know before me whether I'm getting it right or wrong. So, and if I get something wrong, then I just work through it, figure out where I went wrong. Let's just see here. Where we left off. All right. There might be a bit of overlap here. Yeah. So let's just, we're going to finish off with page 40. That's going to lead to a bit of an overlap, but that's okay. Yeah, because we did some of those, but I'm gonna do so there's gonna be like one or two equations where we're gonna overlap. This is 1.3. So we are doing square root of 144 over 324 d squared. Okay. So then that's gonna be 12 times 12. And 324, let's see what we can do with that. All right, 324 divided by 2, So that's going to be 2 times 2 times 9 times 9. So it's 81, and then times 4. All right, and then we have d times d. All right, so this is pretty straightforward. Now, because we have the square root, we have to leave one of our two numbers behind. In other words, we drop a number to be able to pull our number out. Square root, so it just says when we square it, we multiply a number by itself. Here, we're losing one of the two selves in order to get a number back out of the square root. So, for instance, 12 times 12 is 144. If we pull it out of the square root, we just get a 12 out. So we're losing one of the two 12s. So in that case, we're going to have a 12, and then we're going to pull a 2 and a 9 and a d. All right? So then this is going to be 3 times 4 over 2 times 3 times 3 times d. Okay, so then we can drop one of the 3's, and 4 becomes a 2, so it's going to be 2 over 3d. That's what I'm getting. All right. And this was 59. And then we're going to go with 61. This is... So we now, instead of square, we have a quadruple root here. X6 over 16x to the fourth. So the way this works, in order to pull 1 out, so in other words, you have to spend 4 to get 1 back. Just as on a square root, you have to spend 1 of 2, and then you can pull 1 out. You spend 1, pull 1 out, kind of a thing. That's how to mentally imagine this. In this case, you're spending 4 to be able to pull 1 out. So you drop 3, plus 1 comes out. You could think of it that way also. So, let's see what we actually have here. 162. So that's, let's break that down. 162, we're going to divide that by 2, 81. So that's going to be 2 times 9 times 9. And then that's going to be 3 times 3 times 3 times 3. Okay? And then we have times x times x times x times x times x times x. All right, this is a little tedious, but you're going to see where I'm going with this. 2 times 2 times 2 times 2. So we have, times x times x times x times x. Okay. Well, let's just scratch 4 of these here. And we're going to scratch 4 of these here. And then we are going to say We can pull a 3 out. And we can pull a 2 out. So then we end up with 3/2 over quadruple root of 2x squared. Okay? All right. And 63. All right. We have cube root of 128 z to the third minus cube root negative 16 z to the third. Okay, so we can pull a z out. Let's do that right now, right away. That's a simple thing. So we're going to have z cube 128 minus z. So let me think about this for a minute here. Right. Yeah, that's fine. Now, in terms of the negative, I'm going to leave the negative in there. Technically, I can pull it out with the z, but I'm going to leave it in there for a minute. I'm going to leave it with the negative 16. I could have pulled out the negative z, but it doesn't matter. Either way, we're going to get rid of the negative. You'll see. All right. So now we have, well, let's see what we can do with 128. That's what, to the 7th? Okay, so 2 to the 7th, I think. So that's 1, 2, 3, 4, 5, 6, 7. And that's correct. That's 2 to the 7th. And 16 is 2 to the 4th. So we have z. Then we have 1, 2, 3, 4, 5, 6, 7. Minus z 3 negative 2 times 2 times 2 times 2. Okay. So here's what we're going to do. We are going to, well, here, pay 3, get 1 out. Pay 3, get another 1 out. So now we have z 4 cube root of 2 minus z, and then I'm going to pay 3, and I'm going to pay the negative, and I'm going to pull it out. And the reason I can pull the negative out is because this is an odd cube root. When you have an odd power, you can pull a negative out. If not, then you can't. If it's even, you can't do that. So then we have, so we're going to make this plus, and then it's going to be z2 root 2. Still a cube root of 3. So there's a cube root of 2. So now we have 24 cube root of 2. Sorry, z. Not 24. Those are z's. Z's 4 cube root 3 root 2 plus z 2 cube root 3 root 2. So let me make sure I did that right. Yeah, I believe that's right. That should be 6 z 3 cube root of 2. All right, let's check some questions. See how I did here. Okay, we are gonna go back of the book. 59. 2/3 d. Okay, yes. 61. 3 over 2 cube root of 2x squared, yes. And 63 is 6z cube root of 2. All right, yes. Okay, so far so good. All right. Now, this is 1.3. Okay, so we got through 63. Now 65. All right. A guy wire for a suspension bridge runs from the ground diagonally to the top of the closest pylon. Okay. So it has to be, let's imagine we have a pylon here, we have a wire, and then this is the ground. So we're forming a triangle. So we can use the Pythagorean theorem to find the length of the guy wire. And this is pylon with a Y. So we have a guy wire and we have a pylon. Guy wire, pylon. Okay, so, yeah. Just give me the distances. The square of the distance between the wire and the ground of pylon is 90,000 feet. The square of the height of the pylon is 16,000 feet. So the length of the wire can be found. Okay, I see what they're saying. So, a squared, b squared, c squared. So Pythagorean theorem states this. A squared plus b squared is equal to c squared. Okay? And in order to find what the c is, we're just going to, afterwards, we can just square root it. So, for instance, if we have 3, 4, 5 would look like this. 3 squared plus 4 squared is equal to 5 squared. 3 plus 3 is 9, plus 4 is 16, which is equal to 25. Okay, and then, so that's the traditional example would be a, like this, 3, 4, 5. That's a very basic example of a right triangle and using the Pythagorean theorem. Okay, so yeah, in this case, what we have is, they're giving us already the square root. So they're giving us, let's see here, the square of the distance between the wire and the ground, and the square of the height of the pylon. Okay, so this is going to be 60,000, and this is feet, the square of it, of course. And then the square of the distance between the wire on the ground and the pylon on the ground. So this is 90,000 feet. So our triangle actually looks something like this. This is a more accurate visual description of it, okay? So now, but it doesn't matter. We're still doing the same formula. So now all we got to do is we still want the guy wire length. So we have 90,000 plus 160,000, and we're going to square root that, okay? So, right away, if you don't know what it is, it's going to be 25, in a minute. It's a square root, it's going to be 50,000. It should be 50,000, I think. Because, no, wait a minute. Is that going to be 50,000? It looks like it's going to be 50,000. All right, but let's add it up. So we have square root of 90 plus 160 is 250,000, which comes out to 50,000. Now remember, now you might think, that's kind of short, right? But it's not, because c squared is 250,000. 250,000. And the hypotenuse, this is the hypotenuse, is always the longest length. So it's 250,000. Notice what I did there without even realizing it. Now, I gave us the 3, 4, 5 triangle because that's like the simplest one that you can just pop off at the top of your head. Very simple, right? They did the same thing. They just added a bunch of zeros. And they already gave us the squared. So technically, if they didn't give us the square, then it could have been like this. It would have been Okay, this would have been 30,000. I meant, is it? Oh, sorry, it would be 3,000. Is it 3,000? Or hang on a minute. It should be 3,000, I think. Wait a minute. That's too many. That's too many zeros. There we go. So it's actually 300. So without the square, it was 300, and so we're not done yet. I put too many zeros on here. It's 500. Let's fix this. So, because we're gonna lose, so it's 5, and we drop one of the zeros, so it's 500. Yeah, 500 times 500 is 250,000. So our guy wire is, this is the c squared of it, but the guy wire is actually 500 feet. But getting back to what I was saying, we have actually, it was 300 feet, 400 feet, and 500 feet. Those are the actual lengths before you square them. So that was, again, just a 3, 4, 5 triangle. That's it. They just did it a little differently. And again, you could have a 3, 4, 5 looking like this, 3, 4, 5, or you can do this. And this is going to be 3, 4, 5, right? It's just turned on its side, but essentially same thing. I just rotated the size. Okay. And we can verify that. Okay, and 500 feet, yeah. But that's pretty obvious, right? I mean, like, this is very obvious to demonstrate. Carrying on, we have 67. 67 is, okay, root 8 minus root 16 over 4 minus root 2 minus 2 to the half. If we do the half, right, yeah, that's, it just means a root. Yeah, if it was negative, it would drop it in the denominator. Half just means a square root of it. Okay, so let me think here for a minute. All right, yeah. So this 2.5 is equivalent to, it is going to be m over a. Let's just do it like that. And then in which case, this would be the equivalent of saying a to the n over m, right? Essentially, in this case, we have 2 and a to the 1. So in this case, or, well, the a is going to be just 2, right? 2 to the 1. 2 to the 1 is 2, and we have a root of it, so that's just going to be root 2. But before we get ahead of ourselves here, why don't we rationalize the denominator? Right. We're going to say 4 minus root 2. If we multiply that by 4 plus root 2, now remember, if we have a, let's see here, if we have a plus b times a minus b, the result is going to be a squared plus b squared, right? As you can see that, a squared, and then a minus ab plus ab plus b squared. So, and this is what we're trying to get. If we do this, then we're going to get rid of our square root. So now you can multiply top and bottom by whatever you want, because that doesn't actually change, because it still comes out to 1. In other words, I'm still multiplying it by 1, but I'm changing the form of it. But the number, the values won't change. 4 minus root 2. And we're going to multiply this by 4 plus root 2. 4 plus root 2. And of course, if x over x is still going to be 1, right? Doesn't matter. So over here, let's multiply this out. Let's just clear up a bit of space here. Okay. We have 4 times 4 is, I'm just doing the denominator first. We have 16, and then we have minus 4 root 2. Sorry, this is going to be plus, because we're starting with the 4, then we're going to be minus 4 root 2 plus 2 times root 2, which is 2. Okay. And one other thing, hold up. It's not plus. It should be minus. So, because 4 times 4 is 16, 4 times root 2 is 4 root 2, and then we have minus root 2 times 4 is minus 4 root 2, and minus root 2 times root 2 is minus 2. All right, so then these get crossed, and we have this minus 2 gets us 14. So now our denominator is 14, and then to do the top, we have 4 times root 8, okay. And then we have minus 4 root 16. I really should have eased up on those things. I should have solved them first, but whatever. And then we have times plus root 16. So that's 8 times root 8 times root 2. You can merge roots together and multiply on the inside of the roots. And then we have minus root 32. Okay, and let's clean that mess up. So root 16 is just going to be 4. Okay, and then we have 4 times root 16. So that's going to be 4 times 4, that's 16. So we have 4 plus 16. And root 32, I believe that's, what is that, 8? Hold on a minute. No, that's 4 root 2. Minus 4 root 2. Because, yeah, we pulled out, so we got to 16, and then we can pull a 4 out, and that still leaves 2 in there for the 32. And then we have root 8, we can pull a 2 out, that's going to be 8 root 2. So now, and then the negative 16 carries over up here. Let me make sure I got all this right. So then this, we're going to say that's going to be negative 12. And then this is going to be 4. So it should be 4 root 2 minus 12. Now watch me get it wrong, because I wrote like a maniac all in one thing instead of spreading out my equation. This is a very easy way to make a mistake, just by like slapping everything together. Like a teacher wouldn't be happy with the way I did it, because it's just, you can see what I'm doing, but at the same time there's no order to it. So it's just like, it's just manic looking, I suppose. But whatever, let's keep rolling along. Minus root 2. Okay. So let's write it down here. We have 4 root 2 minus 12 over 14 minus root 2. And then we're gonna do this. So we can take a 2 out. That becomes a 7. This becomes a 6. That becomes a 2. All right. And then we're going to multiply root 2 times 7 seventh, and then we're going to merge it. So now we have 2 root 2 minus 14 minus 7 root 2 over 7th, right? All right, let me make sure my numbers match up. And then we're going to say this is going to be minus 14 minus 5 root 2 over 7th. And we're going to take the negative out. We're going to say 14, or negative 14 plus 5 root 2 over 7. Okay. Did I do that right? Okay, so I merged a negative root 2. And let me make sure I didn't screw that part up. And I had a positive root 2 root 2 in there, which subtracted from that, from the 7 root 2, that gave me 5 negative root 2. So that, I think that's correct. Let's find out real fast here. Okay. Let me make sure. This was 67. Yeah, no, I made a mistake. I was close on it, but where did I mess up here? It should be negative 5 root 2. It should be 6 instead of 14. And that's what I said. Watch me screw up, because when you write like a maniac like this, you're going to end up with making a mistake. And the mistake was right here. That's a 6, and I kept it as 14. Because everything was just written too close. Yeah, so that is right here. That's a 6. And that is a 6. Okay. And that is the correct answer. Now, you could also do this. You could pull the negative out, make it a 6, minus on the outside, which of course would spread to both of them if you wanted to do that. So that's 6 plus 5 root 2 with the negative on the outside. Either one's the same. But yeah, that's good. So like my mistake was this 14 right here. I don't even know what that's doing there, to be honest. Right, but it doesn't matter. So that I cover the mistake was afterwards. So good. That was the correct answer now. Let's continue on. All right, so 69. We have. You know what? Let's switch to a finer point, just because these equations are getting dense. So we're going to say mn to the third power. I'm going to try to write neat so I don't have any more failures on account of messiness. C what? So I don't even know what that's supposed to mean. Let me think about that for a minute here. See, I think that just looking at this right here, I think it's meant to be this. It's just saying C minus a cube root, but it doesn't, you can't do that, basically. So I think it's just like a typo, or it's a formatting issue by the looks of it. So we're going to operate under the assumption that that's what they were going with here. Okay. All right. So let me check here. Okay. Let's continue here. All right. We have n times mn. So we're going to pull one of the n's out. Then we have times so if it's a negative like this, a negative power gets flipped. So keep in mind, if it's in the denominator, it goes to the numerator. If it's in the numerator, it goes to the denominator. So in other words, if you have this a over 1/8 b, that's the same thing as saying a times b. Okay, because yeah, it's when you divide by a divider, it flips in on itself. So we're gonna say this is gonna be cube root c to the third power, and we're gonna pull a c out. So it's gonna be a c cube root c root c times a to the 7th n squared m and then c squared. That looks right to me. Where did I lose an a? I lost an a. A squared. Okay. All right. Now, when you have a power times a power, you just add the powers. So when you have a power to a power, that's when you multiply them. Now let's see here. We have nm. First, I have to make sure I didn't screw anything up. So m stays. We pull out an n. A squared stays. The c gets flipped to the top. We pull a c out. Then we have a goes to the bottom. N goes to the bottom. We pull an m out, and we pull 2 c's out of the 4. Okay, and now we're just gonna, let's see here. We're gonna drop, wait a minute. We'll lose the c, and we're gonna lose the square. We're gonna lose the square, and we're gonna, can't do that. That n is contained. Is that all we can do? No, there is an n on the outside. We're going to lose it and lose that. Okay. And the m is contained. All right, well, let's just do it now. We're going to say CMN over a to the 9th and mn. We'll just do mn. mn. That's to the 9th. There we go. A to the 9th over m and n. Yeah, I think that's all we can do with it. Let me see here. A C. I'm missing a C though. Mn. The top is correct. The bottom is correct except for there's a C missing. And oh right, that's C right there. There. Okay. And that is now correct. Okay. So you got to be careful. I take too many actions in one go. Like normally you would supposed to rewrite it each time. You make fewer mistakes that way. So I kind of like just do like 5 operations at a time. That's a bad habit. You really shouldn't do that. Learn from my mistakes. Okay. And so, by the way, if you look at the book, remember how I said about typos? This is like the second typo I found in this book. So when you have, in this case, on 69, they had it written like this. C minus a cube root. And that is an obvious formatting error. What they meant to do was see like that, okay? So that's all. If you see something like that, you can kind of tell, like, this doesn't make any sense. Like, what would that even be, right? It makes no sense whatsoever, so you just have to roll with what you think would be the mathematically logical thing that they were going for. Sometimes you have to get inside their heads and figure out what they're going for, but mistakes are rare. Most of the time, if you're not getting something, don't assume that it's an error. Most likely, you're just not getting something. So, yeah. And if it's like that, that's just like a formatting typo, whatever. Okay. Okay, good. Here we go. 71. And this is 1.3. Okay, we have x and square root of 64 y plus 4 y over, this is a pretty simple one, 128y. Okay, so we can get rid of the y's. Yeah, this is very simple. All right, so 64 is 2 to the 6th is equal to 64. 2 to the 7th is 128, okay? That's what we need to do. So if that's the case, also 8 times 8 is 64, just so you know. And 8 times 8 times 2 is 128. So right away, we can do some easy pulling out. We're going to say x times 8 root y plus 4y. However, here's the thing. I don't think we could add the 2. Sorry. Even though both are root y's, you have an x attached to that. Can you add that? No, I don't think you can, because you'd have to multiply. Here's the problem. We don't know what the x is, right? What if x is 0? Say x is equal to 0. Then this is 0 plus 4 root y. And if we were to do 12 root y times x, that would be 0. So as you can see, we cannot attach the 2 to, even though it's tempting to do that, because before we were in situations where we had a constant. That's it. Constant's basically a number, right? And then we have a variable. This is a variable. That's a constant. The x is a variable. It could be anything. That we don't know what it is. So we have to operate under the assumption that it could be anything that could undermine us. And because of that, we cannot add it in there. So we have to, even though it's tempting to, we can't add that together. Instead, we could simplify this. So the 128 below is going to be, that's 2 to the 7th. So that's 8 root 2y. Okay, and now can we get rid of the root y? And I think we can in this case, because those are multiples. Yeah, that should be fine. So we're going to take out the root y's. All right. And we're going to keep, yeah, because we're going to do this. We're going to say x 8 root y plus 4 root y over 8 root 2 root y. And then we're just going to go scratch, scratch, scratch that. And then we are going to, now as tempting as it is for me, I'm not going to perform multiple operations in one go here. I'm going to rewrite it. And now we have 8 root 2 times x times 8 plus 4. And now we can perform, we're going to get rid of the 4, make it a 1. 8, make it a 2. 8, make it a 2. So now we have 2x plus 1 over root 2. And now we're going to perform one more operation. I'm just going to move this down here. plus 1 over root 2. We're going to multiply top and bottom by root 2 to rationalize it. And that's going to be 2 root 2x plus root 2 over 2. All right, and I think that's all we can do with that. Now, let's take a look. All right, and I made a mistake there. And that's because I didn't carry the 2. Yeah, I make these dumb mistakes. There we go. So this is the corrected answer here. I really got to go back and check my work. But that's it right here. So 2 root 2x plus root 2 over 4. And that's because the root 2, when I carried it over, see right here, I forgot to carry the 2 there. So then that's going to work now. Okay, so that's good. Now, 71. Okay. And 1.373. Okay, and this is the last question. I'm going to try really hard not to make a dumb mistake. So watch me make a dumb mistake. Here we go. All right. 256. Okay, over root 64 plus root 256. All right, so let's establish a couple of things. So 2 to the 6th power is going to be 64, or 8 times 8, okay? And then 2 to the 7th is 128, which is 8 times 8 times 2. 2 to the 8th is equal to 8 times 8 times 2 times 2, and that's 256. So there's a couple of things that we're going to be working with right away, okay? So, however, keep in mind we also have cube roots. So why don't we? And this applies to the whole thing, yeah. So, in the top, we have a cube root of 64. So that means we're paying 3 to get 3 back out. So, in other words, instead of 8 times 8, for the 64, we're able to pull 2 out. So we're getting 4 out instead of 8. All right, so we're going to get 4. And to think about it this way, it's going to 1, 2, 3, 4, 5, 6. And we are going to be, hang on a minute. So if it was a cube root, if it was just square root, on a square, you take half out, you get half back. So you would get 8. But in this case, it's a cube. We have to pay 2/3. So we get 4 out. Okay? So you out of 3, you get 1. In other words, drop, drop, you get. Drop, drop, you get. That's how it works on a cube root. Okay, so we got a 4 there. Now, on the 256, we have 8. 1, 2, 3, 4, 5, 6, 7, 8. So now we're going to pay 4, pay 3, get 1. Pay 3, get 1. Pay 3, get 1. So plus 4. Okay. And over here, we have square root of 64. So 64 square root, we know that. That's 8 times 8. So that's 8 times 8 is 64. So we're getting 8 back. And then we have the 256. And that's going to be 16 back. Okay. So now, and in case you're wondering about the 16, multiply 16 by 16. 16 times, a minute here. Yeah, it's 256. So, so far we have We got 4 plus 4 and 8 plus 16 out, and then we still have a square root over the whole thing. All right, so let's just add them up. We have 8 over 24, which is square root 2/3. And I believe that's all we have. I can't think of anything else we can do here. All right, let's take a look on that. Oh, right. Well, why don't we rationalize the denominator? That's the only thing we can still do. So, while this is true, we can rationalize it further. We can do this. Okay? And then we're going to multiply that by root 3 over root 3. And so now we're going to get 3 over root 6. I think that's correct. Let me check here real quick. Okay. Okay, so now they're getting root 3 over 3, and I'm getting root 6 over 3. So I made a mistake somewhere earlier. In other words, their solution was actually this. They had it 1/3, like that. And if that was the case, let's see, although the 2 was wrong. Let me go back and check my work. It should have been, let's see here, 8. Oh, okay. Right there. Why did I... I really have to pay attention. I make the dumbest mistakes. But hey, that's okay. You get to see how this works. Okay, so we have root 1/3 times 3 over 3. So in that case, let's just, I'm going to fix this last part here. Let's just do this one more time. Okay. And okay. So yeah, sometimes I go too fast, and that's where you make a lot of mistakes just by kind of blazing through it. But we're going to say 1/3, okay? Because that's what it is. It's 1/3. So we're going to say root 1 over root 3, which is also 1 over root 3. We're going to multiply that by root 3 over root 3, which is going to come out to root 3 over 3. And that is the final answer. Okay. Wow. Well, stumbled through a lot of them, but hey, it was a fun little number of questions here. Anyway, yeah, I have no shame on mistakes. I'm not trying to get, obviously I try to get them right, but at the same time, I don't try to hide my mistakes. And for me, it's just all practice. A lot of it is just like, if you take a lot more time to figure them out, take your time to double check everything, your work. Watch out for obvious mistakes. 8 over 24 is 1/3, not 2/3. That kind of a thing, right? You do that, you're going to avoid a lot of the pitfalls that I made. But at the same time, it is what it is. So, it's all a learning process. You got to do math. You got to do a lot of math in order to just keep improving at it. Anyways, I had fun. I hope you did too. Hope you learned something. So join me next time, and then we're going to continue in 1.4. All right, until then. And Merry Christmas for those that celebrate today.